Welcome back to the 5-Minute BTech channel. We've all been there. You run into the store to grab a single carton of milk, head to the checkout, and you end up stuck right behind someone with 2 carts completely overflowing with groceries. Your computer's brain, the central processing unit, or CPU, works exactly like that single, hard-working cashier. The customers waiting in line are all the different applications and background tasks running on your device, from your web browser to your music player. And just like the cashier can only scan one barcode at a time, the processor can only actively handle one single task at any given moment. Since the processor is forced to do one thing at a time, your operating system acts as a manager, deciding exactly who gets served next. This specific decision-making process is called CPU scheduling. The specific rules the computer follows to manage this checkout line completely dictate whether your laptop feels lightning fast and responsive or frustratingly frozen. Let's look at the first rulebook a computer can use to manage the line. It's called non-preemptive scheduling, and it creates a highly rigid system. Under this rule, once a task begins, the processor will not stop or switch to another job until that first task is completely finished. The person with 2 overflowing carts gets to check out every single item before anyone else can move forward. This method has clear advantages. It is extremely easy to program, creates a very stable environment, and requires very little extra effort from the computer to manage. But it forces terrible waiting times onto everything else. If you are holding that single carton of milk at the back of the line, you are going to be standing there for a long time. On your computer, this means a large, long-running background task, like saving a huge video file, would take total control of the system. Your screen, your mouse, and your keyboard would remain completely frozen until that file finished saving. This non-preemptive approach prioritizes system simplicity over your experience, making it highly inadequate for modern devices where we expect things to react instantly to our clicks and taps. To fix this, modern systems use an alternative called preemptive scheduling. Imagine a checkout manager who actively steps in, pauses a large order mid-scan, and lets people with 1 or 2 items sneak through first based on urgency. Watch this massive task begin processing before the system pauses it halfway through. This allows a tiny, urgent block of work to jump in and finish instantly before the large block resumes. This interruption guarantees phenomenal response times, keeping the device highly interactive. But hitting pause comes with a cost. The processor has to literally set the current work aside, carefully save exactly where it left off, and then load up the details of the new task. Computer scientists call this physical shuffling context switching. Think of it like a chef putting away all their ingredients for a cake, pulling out the ingredients for a salad, and then swapping everything back again. It creates overhead, demanding extra time and energy from the processor just to manage the switch. Preemptive scheduling willingly accepts this burden. The computer does more work behind the scenes, paying that extra energy cost, so you get a smooth, responsive experience on the screen. When we step away from the grocery store metaphor and look inside a real smartphone, we see dozens of applications competing for attention at exactly the same time. To handle this chaos, modern operating systems rely almost entirely on the preemptive method. The processor chops massive, ongoing tasks, like streaming a podcast, downloading a software update, and registering your finger swipes, into tiny, microsecond slices. This timeline chart illustrates exactly how fast this happens. The different colors represent different applications, taking turns in rapidly alternating microscopic slices along the central line. The processor context switches between these tasks millions of times per second. It moves so quickly that it creates the perfect illusion of true multitasking. Looking at this matrix alongside the timeline, we can summarize the stark difference. On the left, non-preemptive scheduling is simple and low overhead, but slow to respond. On the right, preemptive scheduling requires complex shuffling and high overhead, but guarantees the fast, instant interactivity we expect today. The next time you are playing an intense mobile game and your phone seamlessly pauses it so you can answer an incoming call, you are experiencing this incredible juggling act happening inside the CPU. Thanks for watching the 5-Minute BTech channel.